Hey guys, I'm going to work through your study guide with you. In this first video, we're going to work through the first 10 problems, and then I'll do another video of the next 10, and then we'll do a video of the last 6. So let's get started. It says, if the codomain is all real numbers, the function shown is, and my choices are neither, 1-to-1, or onto. So let's think about this. What does it mean to be 1-to-1? In order for a function to be 1-to-1, each y value can be paired with only one x value. So if I think about the y value right here, -1, -2, -3, -4, -5. -5 is paired with this x value, and -5 is also paired with this x value. So I can see, and that happens over and over again. It's happening everywhere, because this is a parabola. So all of my y values are being paired with two different x values. So we know that it is not 1-to-1. In order for a function to be onto, we know that the, sorry about that. Someone came to my door. I'm not exactly real sure where I left off, but I know I was talking about 1-to-1, and we said it was not 1-to-1. So now we're going to decide if it's onto or not. In order for a function to be onto, the codomain and the range have to be the same. So let's look at this. It says the codomain is all real numbers. My range, however, if we look at my range starts down here at this point and goes up forever. So it's never going to be any of the values down below this point. So I know that my range is different from my codomain, because all real numbers includes this and my range does not. So we realize that it is neither 1-to-1 nor onto. Next question. It says Salvatore is a plumber. He charges $100 for all work that's completed in less than 2 hours. He charges $250 for work that requires 2 to 5 hours, and then he charges $400 for work that takes between 5 and 8 hours. Which best describes the graph of the function that models Salvatore's price scale? Well, we know it's not going to be continuous. It has to be discontinuous, because it changes the amount of money depending on how much money or how many hours he works. It's going to be the same for anything less than 2 hours. Then there's going to be a break in the graph, because from 2 to 5 hours he's making $250. Then there's going to be another break in the graph, because between 5 and 8 hours he works for $400. So we know it has to be C or D by process of elimination. And so then the range would be, what are my values for my range, my y values? Well, we can see that the range is 100, 250, and 400. So it appears that this is a possibility. And then this one says my domain is x such that x equals 2, 5, and 8. Well, I know that it's not this, because not only is my range 2, 5, and 8, but it's everything less than 2 hours. It's everything between 2 and 3, 2, 3, 4, 5, everything between 2 and 5 hours, and everything between 5 and 8. So this range is, or this domain is not extensive enough. So it cannot be D. The correct answer is C. Next question. True or false? A discontinuous function is always discrete. And I know that this is false, because think about a function that looks something like this. Trying to make a dot here. And then looks like this. This is discontinuous, right? There's a break in the graph. I was trying to make this circle colored in, but I'm having a hard time with my mouse here. This is discontinuous. There's a break in the graph, but it's not discrete. Remember, discrete is just a bunch of random points, and this is clearly not discrete. So this is a false statement. Something can be discontinuous and not be discrete. All right, select all of the functions that are linear. Think about linear equations. What do they look like? Well, linear equations must be in the form of y equals mx plus b. Now it could be rearranged. We know there's also the ax plus by equals c. The important thing is that the exponent on the x variable is nothing other than a 1. If it's anything other than a 1, then it is not linear. So we realize that this is not linear. This would be linear. This would be linear. Look at my x value. Has a 1 and it's in this form. This is in this form. Looking at this is absolute value. If you think about the graph of an absolute value function, it makes a V shape. It's not, it is a line, but it's made up of two lines, so we wouldn't say that it's linear. And then looking at this one, it's tricky. You think, yeah, this has an exponent of 1. But if we were to get the y by itself so that it's in this form, we would have to divide by x. Think back to rules of exponents. If there is an x in the denominator, does it have a positive exponent? No, that's equivalent to x to the negative 1 times 5. So we see that it has an exponent different than 1, so it could not be this one. So what are my answer choices? We came to the conclusion that it was this, and that it was this, and that is it. Number 5. The X-intercept. Well, time is always my X value, so I'm looking, think about X-intercept. For my X-intercept, I know that it is the x, some x coordinate, and then my y equals 0. And for my y-intercept, it's the x coordinate is 0 with some y value. So let's find where is x 0. Or I'm sorry, where is y 0? It's 0 when x is 6, because this is my x, this is my y. And the y-intercept then would be here, so that would be at 80. So we have 6 and 80 as our answers. We can type those in. 6 and 80. Moving on to question number 6. Match each type of symmetry to the correct graph. So this says line symmetry. Well, looking at these, is there anywhere that I could draw a line and it would fold directly on top of itself? So the only one that I see that I could draw a line somewhere and it would fold directly onto itself is this parabola. If I drew a line right down the middle, it would have line symmetry. So I know that one's going to go up here. Point symmetry. So that means if I was to put a point somewhere and rotate my graph around that point, would it fall on itself? Well, I'm looking at this one. I think if I put a point right here and then roll this around, that looks as if it would roll, or that it would fall on top of itself. So I'm going to assume this one is point symmetry. And this one has no symmetry whatsoever. There is no line that I could make. There's no point that I could rotate it about and it's going to end up on top of itself because this side goes down further than this one. So this has no symmetry whatsoever. Next question. It says drag each value of x into the bin if it appears to be a relative maximum or a relative minimum. Now, when I was looking at this a little bit ago, I would have missed it without taking a minute to look back over it because I did the range instead of the domain. Notice it's asking for each value of x, not each value of y. So I went through and I looked at what each of these values were, but I'm not going to pay any attention to the y values because it's only talking about my x's. So we know that this is a high point, this is a low point. So this is a maximum, this is a relative minimum, a relative maximum, a relative minimum. So let's look at all of the x values at each of these places. I've got -1, -2, -3, -4, and -5 is the x value here. -1, -2 is my x value here. Looks like 1 is the x value. 2, 3, 4, 5 is the x value. So now we can go down here and think about what's going to go where. So we know that relative maximum is at 5 and at 1. A relative minimum happens when x is -2 and when x is 5. And I think I missed something very important right here. This has a negative. Otherwise, that's saying my relative max, my relative min are the same. This is an x value of -5, -2, x value of 1, x value of 5. And let's see here, neither. So I'm going to have to delete this and come down here and look at what it gave me. So we said relative maximum at -5, a relative maximum at -2. No, that was a relative minimum at -2, a relative maximum at 1, a relative minimum at 5, and there's nothing extraordinary happening when x is 0 or when x is -4. So that is my correct answers. We've got a maximum at -5 and at 1, a minimum at -2 and +5, and nothing is happening when x is 0 and when x is -1, -2, -3, -4. Nothing extraordinary. No relative maxes or mins. Question number 8. For which function is it true that as x is getting bigger and bigger and bigger, y is getting smaller and smaller and smaller? That's what this positive infinity means and negative infinity. As x is getting bigger and bigger and bigger, y is getting smaller. Well, this right here, x is getting bigger, y's are going down. X is getting bigger, y's are going up, so it can't be that. X is getting bigger, y's are going down, so it's looking like it's these two. X is getting bigger, y's are getting bigger, not that one. And this, as x is getting bigger, y's staying the same, so it can't be that one. So my answers are j of x and g of x. Number 9. The graph shows the height of a ball after being thrown from a height of 1 foot. Explain why the end behavior does not make sense in this context. Look at this. My end behavior shows it down here in the negatives. Does that make any sense that this is the height of the ball? Okay, so it should start at 0, 0, right? The ball can't be higher than 0 feet. Can't be lower than 0 feet when I throw it. So I throw it up, and then what happens here? It hits the ground. My ball is not going to go negative feet into the ground. So it doesn't make any sense to use the negative values here because we know that it just doesn't make sense in terms of the problem. So we want to say, I'm trying to think of the best way to say this, the negative values just don't make sense. The end behaviors do not make sense because it's not going to make sense to consider the ball's height at a negative time or to say that the ball went negative feet. Number 10, last one for this video. Select the functions that could be correctly graphed from these key features. Again, I'm going to kind of think about a picture here. This is a linear equation and it has a negative slope, so it's going to be going like this. This is a parabola with a positive coefficient, so I know it's going to look like this. This is an absolute value with a positive value, so it's going to be a happy V. This one's going to be a sad V. And this is 1/2 x, so it's going to go like this. Okay, the other thing is which has a point located at 0, 0. Well, if I plug in a 0, I get out a 0, so that's good. Plug in a 0, I get out a 0. Looks like all of these, if I plug in a 0, I'm going to get out a 0. So really the only thing to consider is has an increasing value when x is greater than 0. Well, if I look at this one's going down. So it's not increasing for values of x greater than 0. So it can't be that one. This is going up. After we pass through the 0, 0, it's going up. So my function is increasing as x is increasing. So that's a possibility. Same thing here. goes through 0, 0, and then as my x's get bigger, this side's going up. So it is increasing. This decreasing. This one is increasing. I pass through 0, 0, then I go up 1 over 2, up 1 over 2, up 1 over 2, keep on going. So this is increasing for x is greater than 0. So check those off. Nope, not that one. That one, that one, and that one. Moving on. Oh, nope, that was it. I said we were going to stop with 10. So let's just stop our video right there. I hope this has helped.